Just-in-time manufacturing is a pull system. When we look at just-in-time manufacturing, we are bringing the inventory in just when we need it. So we're pulling it from the other parts of our manufacturing process. The idea here is to minimize the safety stock or the amount of excess inventory we hold on hand because holding excess inventory has a cost. It costs to store it. The longer it sits there, the more its value depreciates, and so we have an obsolescence cost. For example, if you are a car manufacturer and you have a number of parts to go into your Ford F-150, the longer they sit there, the less they are useful in future cars. Nobody wants the old technology when they can get the new technology. So you don't want a bunch of excess inventory. So with just-in-time management, we're going to pull the inventory, so the things we need to produce our car, those sub-assemblies and units we're using to manufacture our product, and we're pulling them just when we need them. So let's talk about just-in-time manufacturing and the goals that go with it. When we talk about just-in-time manufacturing, we want a balanced, rapid flow of production. The idea here is that we want to balance essentially the assembly line. That is, we don't want certain workstations to be idle while other workstations are working overtime to catch up. We want a nice balanced production. In order to do that, we need to eliminate waste. We don't want to have to produce a product and then trash it or recycle it because it's defective and then have to go back and make more. So we have waste if we have defective products, we have disruptions if we have to stop and remake. We also have disruptions if we have to wait for parts to arrive. So the idea with just-in-time manufacturing is to not produce excess and to have all the pieces when you need them. So we also want to design a system that has flexibility. That is, we can respond to changes in customer demand. So for example, if you're Ford, you want to be able to adapt your production line to produce, if we're talking about the F-150, an XLT, a Lariat, all on the same line. So you need to be able to do changeovers on your production line. If we're talking about Celestial Seasonings, for example, you need to be able to change your production line to make more herbal tea or make more mint tea based on what the customers desire. So we want to have flexibility in our system. We also want to have a system that is based on continuous improvement. And so TQM or total quality management, is a foundation of just-in-time manufacturing. And total quality management has three parts. The first is that continuous improvement. So you're always striving to find ways to provide better quality, better production. We also want to involve everyone in the process. And we want to focus, of course, on customer satisfaction. As part of this continuous improvement, we want to use a Japanese term called Kaizen. And the idea behind Kaizen is that your continuous improvement should be gradual. No big changes all at once, small little changes. And of course, everyone is involved in these. So everyone is involved. And we're not spending great sums of money to do this. We're not going to buy new fancy technology. We're not going to pay people, consultants, to come in and tell us how our changes should be. Instead, it's going to be internal. What we're going to do is we're going to learn by doing. We're going to come up with ideas that we can apply everywhere. And we're going to get these ideas from direct observation and data collection. So it's the people on the ground floor of our production process, seeing issues, identifying changes that can be made, applying them to the greater production process, and gradual small changes can have big impact. When we look at just-in-time lean manufacturing, the focus really is on reducing the level of inventory and reducing the level of waste. So continuous improvement is very important, so we need to improve that quality. Let's look a little bit more at waste. What kind of waste are we talking about when we talk about eliminating waste for just-in-time manufacturing? When we look at the waste that's involved, there is waste if we have to produce our product, it's defective, and we have to go back and fix it or make more. So overproduction is waste. If, because we are concerned about quality or because we are unsure as to how much product we're going to need, we stockpile our inventory, then that is wasteful. It's going to cost us money. If we have to wait for inventory to arrive, so lots of delays or lead time when we place our order from when it arrives, that's time we're idle. So if we're sitting and idle and waiting for inventory to arrive, that's inefficient and wasteful. We want to eliminate any unnecessary transportation. If we have to rush deliveries of inventory, if we have to work overtime and then rush out what we produce because we couldn't get what we needed in time because we had to remake it, then that's costing us money in terms of sending out additional shipments. We want to get rid of any overproduction and any overprocessing. So overproduction is when we make it more than once. Overprocessing is when we go back and fix it. We want to get rid of any inefficient work methods. So as part of our just-in-time lean manufacturing, we want to go and evaluate our process flow and determine what the most efficient method is for making our product. And as part of that, we will set some standards in terms of the process that we're using. So we'll remove any inefficiencies. Because we are pulling our inventory from wherever it's being processed to where it needs to be next, we can't have there being delays. We can't wait, and inefficient work methods create the waiting, create the delays. If we have to wait for product to be made, then that's time wasted not using it for the product that's in. So for example, if we're making a Ford F-150, if we have to wait for chassis to be made because they're using inefficient work methods, that's causing waiting on the assembly end, which is going to cost us in terms of customer satisfaction. And it'll lead to things like overproduction in the future because we'll make too many just in case there's delays. And then, of course, we have too much excess inventory. We want to reduce waste by reducing any of our production when we're producing defective products. So of course it's a waste to make product that you can't sell. And finally, the waste we want to get rid of is the underutilization of our employees. When we look at the underutilization of our employees, we have two factors to consider. If they're sitting idle and they're waiting because we have to rush an order because inefficient work methods have been used, then we are underutilizing our employees' skills. Our employees are also very knowledgeable. And so the idea here is that Continuous improvement involves everyone, empowering your employees to make changes. So when we talk about eliminating waste, we want to make sure that our employees are involved in coming up with ways to increase our quality and make us more efficient, so we're better utilizing their knowledge for our company. So let's talk about how we do that. How do we design a just-in-time process? Well, to design a just-in-time process, we want to make sure that we balance the workload across workstations. So what we're talking about using the assembly line balancing that we talked about for product layout. We want our process to have flexibility. So how do we create flexibility within our company? Well, we can do things by reducing change over time. When we talk about change over time, we're talking about a production line like Ford changing from an XLT to a Lariat on their production line, Celestial Seasonings changing from herbal tea to mint tea. So often that requires cleaning equipment, that could require reprogramming equipment for the different specs of what you are producing. So in that case, the ways to reduce change over time include things like having cross-trained employees, so they're able to work in different areas. Using small multi-purpose machines. And keeping some idle capacity. Now remember, we don't want too much idle capacity because the whole point of just-in-time manufacturing is to get rid of waste, including wasted time, but we do need a little bit of idle capacity to allow for those changeovers. We also want to keep some safety stock. Now again, just-in-time manufacturing is about eliminating all of that excess inventory, but you do want to keep some safety stock. And the reason is because as you are looking at your workload balancing, you need to consider your bottleneck. And we talked before about the theory of constraints, and you need to make sure your bottleneck is never idle. To do this, you always keep a bit of excess inventory, so the bottleneck always has something to be working on. As we talked about the theory of constraints, we also talked about the importance of having small batches or lot sizes for your production. The idea here is that the bottleneck is your biggest capacity constraint. It's going to limit the amount you produce. And so to have a nice balanced rapid flow, then your inventory should move through your system in lot sizes slightly smaller than what the bottleneck can handle. And that way you continually move your inventory through the process and you're not having a huge amount of inventory that just piles up in front of the bottleneck. We want a small amount, but not a large amount. We want to focus on reducing our setup time. So all production time needs to be value added. Setup time is not, so we want to reduce this or minimize this as much as possible. This can be done by having these small multi-purpose machines. So if you already have machines that are able to do different types of production, that'll reduce your setup time. Your cross-trained employees will also help reduce that setup time as well. We want to use a cellular layout. And if you recall, the cellular layout was a hybrid between product layout and process layout. So product layout is kind of like a car wash. And the downside to product layout or assembly line is that if one part of your production process goes down, the whole line goes down. The process layout, like say the emergency room, where materials move to where they're needed, the problem with this is you had lots of work in process inventory. Lots of pieces of partially created product sitting and waiting. In the emergency room, this is a injured or ill person just sitting and waiting because the doctor is busy or the x-ray room is being used. So the cellular layout is a hybrid between the two. And so just-in-time management uses a cellular layout. For number 6, for designing a just-in-time process, we want to prevent defects. Let's try that again. We want to prevent defects before they happen. And so one way to prevent defects before they happen, or quality assurance, is to use what is called a poka-yoke. Poka-yoke is a Japanese term, and essentially it is a small item, inexpensive, simple technique to prevent defects before they happen. So in class what we did is we looked at the video where they make windows. And so when they insert the glass into the windows, there's a sticker on one side of the glass. This ensures that the glass is put in the correct direction, because the last thing that the installer does after putting in the window is they put a check mark on that sticker. Well, the sticker's only on one side of the window, so if they can't write on the sticker, then they know they put it in improperly. Other examples of poka-yokes would include when you go to the bank and pull money out of the ATM. So when you put your card into the ATM, you ask for your cash. When your card is being returned to you, you'll notice it beeps until you take the card. The idea here is to warn you that your card is there and not to forget it. New ATM machines actually won't even dispense your cash until you've pulled out your ATM card. So here we're preventing the loss of an ATM card or the theft of an ATM card before it happens. If you don't take your ATM card, after a couple minutes the machine will suck the card in, and that way it can't be stolen if it does get left behind. So we can see these are simple steps to prevent the defects before they happen. We talked before about when you design a just-in-time process, we want to standardize your production process. Again, going through your process flow and determining inefficiencies, where your quality might be at risk, and coming up with a standard method for production. And finally, when it comes to designing a just-in-time process, we want to have as little inventory as possible. Traditionally, inventory serves as a buffer, protection against inefficiency, against defective products. The idea with just-in-time management is to take away that inventory that is that safety net or that buffer. So if you think about it as, here's the water level, and see how the water is up above the rocks. The rocks are defects, problems, inefficiencies. As long as the excess inventory is high, we can ignore those inefficiencies and defects because we have extra stock in case what we go to sell is defective. Okay, so it's protecting us, the buffer, but it has a cost, storing that material. The loss of value, the money that's tied up in that material not being spent on value added. Well, if we get rid of that excess inventory, then what happens is it exposes the inefficiencies and the defects. So rather than add excess inventory back, which is often the incentive when we look at other forms of dependent demand inventory management like material requirement planning, instead, the idea here Instead of having that incentive to add a little bit more extra time, instead of adding a little bit extra safety stock, instead what we do is we focus on getting rid of the defects, getting rid of the inefficiencies, getting rid of the big rocks, so you can keep that inventory low.